Well, hello there. This is the Chapter 3 study guide, also called the Chapter 3 review. And of course, this covers the igneous rock chapter, which I will illustrate that by showing you a nice, pretty cute little volcano. So here we go. This is question number 1. So the word igneous, is that a German word, a Latin word, or could it possibly be a French word? So what do you think? And the bigger question is, what does igneous mean? So of course igneous is Latin for fire. So I think we just answered that. Question number 2, we have a nice volcano with some molten rock down below. What is that molten rock called if it's still inside the earth? And when it's erupting from a volcano? Okay, so same question. What is that stuff right there? Well, of course, it's all magma because magma is molten rock. But if it's erupting on the surface, that magma is now called lava. So again, the same volcano with some nice molten rock down below, which of course is called magma. And there are some things that are erupting on the Earth's surface. So is that an example of intrusive or extrusive rock? Of course, if it's found on the surface of the Earth, that is an extrusive rock. And if this magma chamber down here, if it were allowed to completely cool off and to solidify, it would form an intrusive igneous rock. So number 5, here we have a map of the world. And what I'm looking for in this question is what percentage of the Earth is covered by igneous rocks and or metamorphic rocks? And that is your question. The answer, of course, is 95%, and 5% is covered by sedimentary. So now we go a little bit closer to home, and I show you the basic broad outline of the Appalachian Mountains. And the core of this mountain range probably is consisted of or made of what type of rock? First of all, would it be igneous, sedimentary, or metamorphic? And if you said igneous, then what igneous rock is likely to be down there? And of course the answer is, well, you have to determine that. Is it going to be basalt, which is an extrusive igneous rock? Or is it going to be granite, which is an intrusive igneous rock? And if you answered B, then you would be correct. Question number 5, same type of magma. Okay, what we're looking for in this question is what is in that magma? So the first thing, of course, is solids, little chunks of crystals. And what would the L word be? Of course, that's liquid. Liquid is also known as the melt. And then trapped inside of that magma are volatiles, which is basically all the gases that are trying to escape. Question number 6, I'm drawing a nice igneous rock for you, but I'm not going to draw the whole thing. You must think I am completely mad. So what would be its texture if you can tell from my little drawing that it's got big crystals and little crystals? So yes, that would be a porphyry or porphyritic. And oh, I see some quartz there. So if you have some quartz in it, what is its composition going to be? So that would be felsic, of course. So here we have a couple of different categories. We have felsic, starting off. What mineral is likely to be in a felsic igneous rock that starts with the letter Q? Okay, there's other minerals in felsic igneous rocks, a big broad family of minerals that starts with the letter F. Intermediate is kind of a mixed bag of all sorts of stuff. Really, the easy way to remember intermediate rocks is that it does not contain the Q, nor does it contain the O, which is in mafic. So which mineral is green and starts with an O, which probably isn't a mafic rock? Now, you have a choice between the H mineral and the A mineral, and these are two minerals that look very much alike, and those are likely to be found in a mafic igneous rock. Then, of course, you have ultramafic, which is probably going to be totally green because it's going to be loaded with the O. Now the arrow that I have drawn above the three circles, is that showing, is the arrow pointing toward the direction of increasing silica content or decreasing silica content? So of course that way toward the felsic end would be toward the increasing silica or quartz content. Okay, question number 7. We're now going to go over the texture names. So we begin with the name that starts with an A, which means fine-grained. And the A word, of course, is aphanitic. So is an aphanitic igneous rock going to be intrusive or extrusive? So that would be extrusive, of course. The next texture name starts with a pH, and it means that it is a coarse-grained igneous rock. So what is the pH word? So that's phaneritic, and it is intrusive. Next we have the mixed texture, which starts with a POR, which I'm showing here, which has big chunks and little chunks. So POR stands for porphyry or porphyritic. And the big chunks in a porphyritic igneous rock are called what? Phenocrysts. And the fine stuff is the GM, which stands for ground mass, or the Keanu Reeves movie, The Matrix. This one is not loaded with big crystals, it's loaded with holes, so that's the V word, vesicular. This one has conchoidal fracture and therefore is a G texture, which is glassy, of course. Does a glassy igneous rock cool fast or slow? And that, of course, is very fast. Next, I draw a volcano for you with some things erupted from a volcano that is nice and layered. So that is PY something. Pyroclastic. And finally, if we have a nice magma down below the Earth and it cools extremely slow over millions of years, it could form huge crystals like the ones in the Cave of Swords. So that is my favorite. That is a pegmatitic texture or pegmatite. And that is you on the verge of discovering the pegmatite. So question number 8, let's have a little chart now. So we have the F, we have the I, we have the M, and we have the UM. So what do those categories mean? So now we're going to fill in some rock names. So the G word that is underneath the felsic column, and it's something you don't want to take, of course, is granite. So next is a A word that's under intermediate. That's andesite. Under the mafic category, we have a GA with 2 B's. So that, of course, will be gabbro, and then I'm just going to skip the ultramafic. So what is the extrusive equivalent of granite in the felsic row that starts with an R? So he's rhyolite. What is the salt and pepper one, which is intermediate? That's diorite. And the B, which is the most common extrusive igneous rock in the world, is basalt. So question number 9 is, we consider going down into the earth, maybe an elevator, maybe Superman. What is happening to the temperature? Is it increasing or decreasing? And this phenomenon is known as following the geo-something gradient. It's called geothermal gradient. So now what I'm going to do for you is draw a little box, and it poses a question. So how would arrows be drawn on the box to show confining pressure or confining stress? So how would you draw a confining stress? So here I'm drawing the arrows on all sides, basically making the box smaller. So the big question of why I'm going through all this confining stress stuff, excuse me, is to ask, does the increase in confining pressure as a rock goes down into the earth, do you think that'll have a tendency to increase or decrease the melting point of the rock or the minerals that are in the rock? And of course the answer is, the further you go down into the earth, the hotter it gets, the more pressure it's under, and the higher the melting point. So in other words, if a mineral melts at 300 degrees Celsius or Fahrenheit at normal temperatures and pressures, If it's under a tremendous amount of pressure, it might melt at 900 degrees Fahrenheit. So that means it's going to take even more heat to melt it. But of course, there's going to be more heat down below anyway. So question number 11 is a picture of a rock, and that is what? Okay, of course, that's a granite. That is granite. That granite has what composition? So you have to think about your composition choices. There are 4. And the texture of this granite, can you see all the crystals, some of the crystals, or none of the crystals? And its origin. So let's go back to composition. It is a felsic igneous rock because it's light in color, and even in the picture I can see quartz. And because I can see quartz and other things, that means that it's phaneritic. It has big crystals, and a phaneritic igneous rock means that it cooled very slowly, so its origin is intrusive. So here we are with question number 12, and we got a wide variety of rocks that are already set in their respective compositional categories. What I want to know is what compositional category is right here where the question mark is drawn, and which elements are going to be prevalent in that category. So of course that's the ultramafic column, and it's going to be ferromagnesian, which stands for iron and magnesium. Over here in the felsic side on the left, that is non-ferromagnesian. And now we come to the Bowen's reaction series, which is shown here in the picture. This mineral that I'm highlighting, is that a high temperature or low temperature mineral? So in other words, does it take a lot of heat to melt it, or not a lot of heat to melt it? And what about the Q? High or low temperature? So of course olivine is a high temperature mineral, quartz is a low temperature mineral. Do you know what discontinuous branch means? And do you know what continuous branch means? So I'm going to leave the mystery of those up to you. So now we're going to finally conclude our Chapter 3 review by talking about how magma compositions can change over time, or magma compositions. So we have a magma that's loaded with mafic stuff at the bottom, and it kind of grades up maybe toward intermediate, and we have felsic stuff at the top. So when you have the heavy stuff falls to the bottom of the magma chamber and it gets lighter and lighter and lighter, which concept is that called? And that is known as magmatic differentiation. That is what it's called. So the magma is differentiating by composition. You're getting mafic stuff at the bottom and felsic stuff at the top. Okay, here's more ways in which the magma chemistry can change. The little X's and things that I'm drawing is representing of an igneous rock, typically granite. And with this magma intrusion, because the big blob there is magma, it's intruded into this igneous country rock or host rock, and there are chunks of it that are stuck or get trapped inside the magma. So this magma could very well be mafic in composition, but the country rock could be felsic in composition. So of course when you have chunks that are incorporated, or the other word I'm looking for, into this magma, then it will change its composition. So that of course is known as assimilation. Now it looks like there's many pieces that have already been assimilated, which of course are not shown because they're already engulfed with the magma, but the big chunks that you see there, those are called xenoliths, so that may come up in the lab. The final thing that we'll talk about here in our Chapter 3 review, this is kind of a weird picture showing two magmas that are coming together. The magma body on the left is felsic, and the magma body on the right is mafic. So when they merge, you're going to have an intermediate composition magma. So what is it called when two magmas come together and have a party? So that, of course, is called magma mixing. Okay, now let's have a little fun with our last slide. Can you recreate all the minerals of the Bowen's reaction series? There's the O, the P, the A, and the B, which is a mica. Down here we have the other mica, which starts with an M, and of course the Q. Over here on the right side, which is a continuous branch, we have a Ca, an Na, and finally a K. Okay, and that concludes our Chapter 3 review.